Today I'm going to talk to you about different capability levels for AI data management. I'm going to walk you through the evolution from vector database to AI data platform. All of this is about the builder, the developer who's building generative AI applications. And for this person, for this developer to achieve his job, he has to build a lot of things. Right? And I'm going to walk you through those things that he has to build. And typically, the developer needs a lot of support from experts. From experts like data scientists who know things like generative AI models, from data engineers who know how to prepare and wrangle data. So that's the typical setup of a team that you need to build a successful generative AI application. But let's look what is entailed here to build such an application. So one of the things that obviously needs to happen is that AI is about data. You need to capture this data. So data has to be captured. And then you have to also prepare this data to make it ready for consumption for your AI application. So there is a lot of data prep that needs to happen. This data preparation very often includes the usage of AI models. For instance, to do things like classification. For example, to detect, is this hate speech, some data here. That's a classification that where you're applying a certain AI model. And you have to understand which model is suited. Maybe you have to fine-tune this model. There are a lot of details entailed here to achieve this step. Once the data has been prepared, for instance, with the help of some models like classification models, of course you have to store this data appropriately, reliably, securely, efficiently, and so on. And you have to make it available for data retrieval. So you have to implement data retrieval methods that this data can also be used when needed by your application. In order to achieve that, this data retrieval, a method is employed that is called vector embeddings. So you have to compute these vector embeddings. Again, this is an application of an AI model. So this is part of this step here. This can also include so-called embedding computation. And you need to store these embeddings, or these vector embeddings, or vectors. And you need to index them so that the methods of accessing it is a search method, that the search method is efficient and very low latency. And then, of course, you need to implement the according vector search itself. More advanced generative AI applications then piece it all together into retrieval augmented generation flow. Right? Retrieval augmented generation, I'm referring to our other videos that go very deep into this. Retrieval augmented generation is a method to piece certain of these steps together in order to generate actual data. So retrieval augmented generation is a method of data generation, which involves the usage of large language models. So they are entailed here in this step, the integration, the communication with large language models. In certain cases, in more advanced situations, you may want to not just use an off-the-shelf large language model. You may have to fine-tune it. And additional things that typically also need to be done is you need to manage the context of your large language model prompts. So a context is the complete input that you're putting together when you're interacting with a large language model. Right? And this includes, of course, data that you may have stored and retrieved with RAG from a vector database or with the help of a vector database, but it includes also other things, like, for instance, what are the instructions that you're sending to the large language model? Right? It should, for instance, impersonate a friendly agent. Right? So these are so-called prefix information that you need to basically attach to your prompt to tell the large language model what it should behave like. Or you also need to remember the conversational context. Right? What are the previous questions and answers that have been sent so that the model knows with the new request, okay, this has already been discussed, and now I'm basically going to the next step. So all of these things require a lot of expertise. And that's what actually is slowing down the developer to build AI solutions. And that's why he needs a lot of help and a lot of expertise or actual experts. Like for instance, you may have to employ a data engineer, let's say, to build you a data lakehouse as a means to store your AI data, large volumes of documents and things like that. Now, let's look at this, how we can package up some of this to accelerate the work of our AI builder. The most basic capability level that we can define is a vector database. And in fact, that is sort of table stakes nowadays. A vector database is an established capability level today that you find. You find vector databases of multiple colors. And they do storage of vector data, indexing into vector search. Okay. However, the next level that you can see here is storing the actual AI data itself and retrieving AI data, not just the vectors of the data. This is what we call an AI database. It's the next level of capability that basically would exist. If you have an AI database, then you don't have to take care of all of that as a solution developer. You just basically have to take care of this one. And finally, when we look at above here, all of those more advanced, sophisticated aspects of building generative AI applications, if you have something that builds that for you out of the box, that's what we call an AI data platform. The whole objective for adopting an AI database and eventually an AI data platform is to get rid of the need of these skills, or actually the need for these experts here, so that the AI builder becomes more self-sufficient and have a much more shorter time to market for building generative AI solutions.